Hello, hello, hello. Can you hear me? Am I audible, guys? Can you hear me? Yes, hopefully. Let me just check once. So this is our fourth lecture on recursive series. Yeah. Fourth lecture on recursive series. Amazing. Good, 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 good. Yeah. So, what's up? All good? Having fun? Today we are going to do some practice questions. Okay, we have reached a certain level. So we have information of arithmetic progression, geometric progression. We know how to solve an AGP also. Correct? If I'm not wrong. I hope you guys practiced also. In the meanwhile, while I hope some PYQs you have also gone through and some I've bought for you. Some good questions, some practice questions as well as PYQs. Yes. So let me give you a little bit of kind of introduction towards what we are going to do. Okay. One or two practice questions I'll make you do. So there is one thing called telescoping, right? There is one thing which we understand, which we call as telescoping of the recursive series, right? Telescoping means the fundamental idea behind the word telescoping or telescopic series is that series might look very big, but when you look closely with telescope, when you look closely with a telescope, you will see that no, series is not that of big also, it's very small, and we can solve it very easily. For example, the series which is over here, if we look at this series, now what happens is whenever this is not 1.2 for your information, this is 1 multiplied with 2, okay, 1 into 2 and 2 into 3, so this is 1 by 2 kind of, this kind of series, this is this kind of series, this is 1 by 2 plus 1 by 6 plus 1 by 12, right? So 2 into 1, then 2 into 3, 1 into 2, then 2 into 3, then 3 into 4. Now whenever this happens, what you can do is, you can, you closely observe the difference between these terms, right? The terms which are being multiplied in the denominator, you closely observe the difference between terms. So 2 minus 1 is 1, 3 minus 2 is 2, 4 minus 3 is 1, 3 minus 2 is 1 and 4 minus 3 is 1. The difference between the product terms is constant. Okay, so what we can do, we can write the same thing as 2 minus 1 divided by 2 into 1, right? Plus 3 minus 2 divided by 3 into 2, plus 4 minus 3 divided by 4 into 3, right? And likewise it will keep going on. So n into n plus 1 is the general term, right? 1 by n into n plus 1 is the general term. If I talk about the general term seems to be like this. Tn is what? Tn is 1 divided by n into n plus 1, right? Where n is starting from 1 and going till n, right? This is our general term. But here, this kind of series we don't need to solve by using the general term. So any term, let's say the nth term, we write 1 by n into n plus 1. Okay, this is the nth term. Now if we see, now a minus b divided by ab is what? A divided by ab minus b divided by ab, correct? This is what we are going to do, right? A minus b divided by ab is nothing but 1 by b minus 1 by a, correct? So same thing we can do over here. That means 2 divided by 2 into 1 minus 1 divided by 2 into 1 plus 3 divided by 3 into 2 minus 2 divided by 3 into 2 plus 4 divided by 4 into 3 minus 3 divided by 4 into 3, right? Here also, this term also we can break and write. We can write it as n plus 1 minus n divided by n into n plus 1. Right, so last of the terms will be 1 by n minus 1 by n plus 1, right? The bigger term we are writing first, so it's better that n plus 1 by n, this will be what? 1 by n minus 1 by n plus 1. right? If we pay attention, what is happening? 1 minus this is what? 1 by 2 plus this is what? 1 by 2 minus this is what? 1 by 3. This is what? 1 by 3 minus 1 by 4 plus 1 by 4 will be there, and it will keep going on like this. When we see this, these terms are going to get cancelled. This is what we call telescoping. That means when we looked closely, the series is not that big also. It is very small series. Okay, n plus 1 minus n upon n into n plus 1. Yeah, that's correct. Okay, so you can see that till here, last term, everything is going to get cancelled. All the terms, we started from here, till the last term, everything will get cancelled. So whatever this is, sum of all the n terms will be nothing but 1 minus 1 by n plus 1. Right? Only last term will remain because there is nothing to cancel it. Second term with third term with fourth term, last term will remain, nothing is there to cancel it. So 1 minus 1 by n plus 1. This is our sum of n terms. What are they asking? So we'll solve this n plus 1 minus 1 divided by n plus 1. So this is nothing but n upon n plus 1. This is sum of n terms. We can clearly see, and just understand this, learn this very closely, right? 1 by n. Okay, or you can simply write it like this also, 1 upon 1 minus 1 by n plus 1 is your, here is your answer. Okay, 1 minus 1 upon n plus 1 is your final answer. If you look here also, same thing. Here 7 minus 3, here you will do 7 minus 3 divided by 3 into 7. The difference is constant. 7 and 11, difference is constant. 11 minus 7 divided by 7 into 11, right? Here what will you do? 15 minus 11 divided by 11 into 15, till nth terms, right? So 2n plus 1 into 2n plus 4. Okay? 2n plus 1 into 2n plus 4 is your general term. You can write like this. 2n plus 4 is your general term. If you don't want to apply sigma this way also, you can do. So this will become what? 1 by 7 divided by 3 into 7 will be 1 by 3 minus 1 by 7 plus 1 by 7 minus 1 by 11 plus 1 by 11 minus 1 by 15, and it will keep going on like this. So here what terms, but one thing which we need to do, because the common difference is 4. So 4 is being multiplied in the top, so we'll have to divide by 4 also to balance the things, right? 1 by 4 also we'll have to do. Correct? So what will this become now? This will be 2n plus 4 minus 2n plus 1. 3. 2n plus 5 it will be, no? Higher. 2n plus 5 it will be. N is 1, so 2n plus 1 will be 3, and 2n plus 5, yeah, 2n plus 5 it is, 2n plus 5, yes, 2n plus 5 will be your general term, divided by 2n plus 1 into 2n plus 5. So when you telescope it, all these terms are going to get cancelled. What will you have eventually? 1 by 3 will remain, minus, which term will remain from here? 1 by 2n plus 1 minus 1 by 2n plus 5. So 1 by 3 minus 1 by 2n plus 5 will remain. The last term will remain. This will be your sum of n terms. That's it. Now if you want to find the sum of 100 terms, just put n as 100 over here and you will have sum of 100 terms. This is what we call telescoping. Alright guys. Did we understand this? Did we understand this? Are we clear over here? Okay, ji. Right, now let's see some questions which are specifically for RMO and IOQM. Okay, let's do one more like this. For example, here also what do you have? Here also telescoping will happen, because 4 minus 2 is 2, 5 minus 3 is 2, 6 minus 4 is 2. That way you can do the telescoping here also. Suppose if I do 4 minus 2 divided by 2 into 3 into 4, right? Plus here 5 minus 3 divided by 3 into 4 into 5. Plus 1 divided by, plus here we'll do 6 minus 4. 6 minus 4 divided by 4 multiplied with 5 multiplied with 6, right? Keep doing that. And here we'll have 102 minus 100 divided by 100 into 101 into 102. Why did I do this? Because I know that the difference, this difference is fixed. This is 2. This is 2. So I'll just divide by 2 to make things balance, so that things get balanced. Now what is happening? See, 1 by 2. Over here what do we have? 1 by 2 into 3 minus 1 by 3 into 4 plus 1 divided by 3 into 4 minus 1 divided by 4 into 5 plus 1 divided by 4 into 5 minus 1 divided by 5 into 6, right? This way. So these terms are getting cancelled. All these terms will get cancelled. Here what will you have? 1 divided by 100 into 101 will get cancelled. 1 divided by 100 into 101. This will get cancelled, right? Minus 1 divided by 101 into 102 will remain. This will remain. So basically what do we have? 1 by 2 into 1 by 6 minus 1 divided by 101 into 102. Okay. This thing is given to you equal to k divided by 101, and likewise you can find your k also. So telescoping means looking closely. This is what the scenario is. Are we clear? Okay. So you can see your answer will be 286. 286 will come as your answer. When you solve this, you will get k is equal to, 34k they have asked. So 34k will be equal to 206. Okay, ji. So this is one thing, and this is used a lot of times in our questions also, PRMO questions. Now let's do some practice with some PYQs, or previous year questions, and some good questions based on recursive series. All right. For example, let's start with this question. In a geometric series of positive terms, the difference between the 5th term and 4th term is 576, and the difference between the 2nd and 1st term is 9. What is the last 2 digits of the sum of first 5 terms of this series? Basic GP question. Okay, we should have knowledge of AP GP in good depth. Okay, good in-depth knowledge we should have for AP GP, AGP, and telescoping if we want to solve the questions of PRMO. Okay, so they are saying geometric series of positive terms and the difference between the 5th and 4th term. So AR square, AR cube, right? AR to the power 4, AR to the power 5. This is what we have. AR square. Here it will be AR, here A. Okay. So 5th term is AR to the power 4, right? 5th term will be AR to the power 4, and 4th term will be AR cube. So T5 minus T4 is given to us as 576. By this we understand that A is the first term, R is the common ratio. So AR to the power 4 will be the 5th term, and AR cube will be our 4th term. This difference is given to us as 576. No problem. Then they said the difference between 2nd and 1st term, 2nd term and 1st term. 2nd term will be AR, 1st term will be A. This difference is given to us equal to, this is given to us, 1st term is 9. So we understand that AR minus A is equal to 9. Right? From the first equation, what do we understand? So AR cube, if I take common, then I have R minus 1 over here. Okay. And from this one, if I take A common, then R minus 1 I have, and 576 divided by 9. I just divided these two equations. This is first and this is second, because I want to solve, no, I want to get rid of A. So I got rid of A directly, and I got rid of R minus 1 also, and R cube I am directly getting. This is 9 8s are 50, 9 6s are 54, 3 6 9 4s are 36, so 64. I get R cube is equal to 64. Now R definitely has to be positive because it is the geometric progression of positive terms. So definitely there is only one solution, that R is equal to 4. Now they are asking what is the last 2 digits of the sum of first 5 terms of this series. Sum of first 5 terms, sum of 5 terms. That means what is the sum? A into r to the power n minus 1 divided by r minus 1. This is our sum formula, sum of 6 terms. So that means A into r to the power 5 minus 1 divided by r minus 1, right? What is our r? 4. So A, and if r is 4, we can also find A na. If r is 4, then AR minus A, that means 4A minus A is equal to 9. That means 3A is equal to 9. That means A is equal to 3, R is equal to 4. A is 3, R is 4. So 3 into 4 to the power 5 minus 1 divided by 3. That means 4 to the power 5 minus 1 will be our answer. And last 2 digits we need to tell. So can you tell me the last 2 digits? For cyclicity you can use, right? 4 to the power 5, otherwise also you can 2 to the power 10, 1024 minus 1, that means 1023. This will be 1023. What have they asked? What is the last 2 digits? 23 is the last 2 digits of the sum of first 5 terms. S5 we need to find out. So this is our formula. I hope we are clear. Any comments, anything? Next question. Next question. Okay, let's go ahead. Next, this is a very good question. Try it. Give it a try. It is saying that there is a sequence recursively defined, that this sequence is recursive. They have already told. So you have to believe in it. Okay. F0 is 0. That means 0th term they are saying is 0. F1 is equal to 1. And Fn is the remainder when Fn minus 1 plus Fn minus 2 is divided by 3. For all n greater than equal to 2, thus the sequence starts like this: 0, 1, 1, 2, 0, 2, and this the sequence also they have given. Now they are asking what is this sum? F2017 to F2024. What is this sum? They want to know this. So how? Whenever this type of thing happens, that they are giving you terms to make the sequence. You don't know which type of sequence is this. So best approach is that you understand this sequencing, this term definition. Term definition means what do we mean by Tn, what do we mean by Tn plus 1, T0, something like this. So F0 they are saying that this is equal to 0. F0 is equal to 0. F1 they are saying is equal to 1. F0 is maybe 0th term, 0th position. They have defined it like this. Okay, position. Now Fn, any general term, Fn is defined for n greater than or equal to 2, because 0 and 1 they have already given. Now Fn is defined for n equal to 2 or greater than 2. Fn is what? Fn is the remainder obtained when Fn minus 1 plus Fn minus 2. This thing is divided by 3. This thing is divided by 3. First of all, you tell me, what is the remainder when we divide 1 by 3? What do you think? What is the remainder when 1 is divided by 3? What is the remainder, guys? You tell me, what is the remainder when 1 is divided by 3? Can you tell me? Can you think of it? Right? For example, if I want to find second term, F2 will be remainder of what? Remainder when second F2 minus 1, that means F1, plus F2 minus 2, that means F0, right? So F1 minus F0, just a second. Okay, F2 minus 1, okay, F2 minus 1, that means F1 plus F0. This sum is divided by 3. So F0 plus F1 will be equal to 1. That means remainder of 1 divided by 3. What is the remainder when 1 is divided by 3? The remainder when 1 is divided by 3 is 1, is equal to 1. Right? You can believe it. If you don't believe it, then just think like this. When I am dividing 1 by 3, what am I doing? 1 does not go in 3. So 3 zeros are 0 and remainder will be equal to 1. If I am dividing 2 by 3, so 3 zeros are 0 and remainder will be 2. Okay, now you can believe, right? Mostly students do know this, but remainder, after that you apply decimal. Decimal you apply after getting the remainder. ठीक है? तो all right, so remainder is 1. Yeah, 0 1, first 0th term is 0, first term is 1, f1 is 1, then f2 is, this is f2, f2 is what? F2 is again 1, then f3 will be equal to what? F3 will be remainder when f2 plus f1, 3 minus 1, 3 minus 2 is divided by 3. 1, that means remainder when f2 is your 1 and f1 is 1. So 1 plus 1 is divided by 3. That means remainder will be equal to 2. Right? Remainder will be equal to 2. Similarly, if we write f4, f4 will be remainder when f3 plus f2, that means 2 plus 1 is divided by 3. So f4 will become 0. What will be f5? When f4 plus f3 is divided by 3. So f4 is 0, f3 is 2. Right? 0 plus 2, 2 divided by 3, remainder will be equal to 2. f6, you can check also, this series is going like this. Right? f6 will be what? f6 will be, you have to write some terms to see the recursion, because right now we are not able to see the recursion, no? So it's better we write some of the terms so that we can see the recursion. f6 will be what? f6 will be f5 plus f4 divided by 3, that means 2 plus 0 divided by 3, that means again 2. Right? f7 will be equal to what? f7, this plus this divided by 3, that means remainder will be equal to 1. What will be f8? f8. So you see the first term has not repeated yet. Right? f8 will be what? 1 plus 2 divided by 3, remainder will be 0. f9 will be equal to what? 0 plus 1 divided by 3, remainder will be 1. f10 will be equal to what? 1 plus 0 divided by 3, that means remainder will be again 1. You see, if we see 0 1 1 2, 0 2 2 1, again 0 1 1 has come. Okay, you see, can you see this? Again 0 1 1 has come. Is it repeating? Write some of the terms. You will realize. Write some of the terms. Write some terms. Again 1 1 has repeated. Now again if you see f11, I am going to write some of the terms. 1 plus 1 divided by 3, remainder will be 2. f12, 2 plus 1 divided by 3, remainder will be 0. f13, 2 plus 0 divided by 3, remainder will be 2. f14, 2 plus 0 divided by 3, remainder will be 2. Right? Correct? f15 will be what? 2 plus 2 divided by 3, remainder will be 1. f16, 1 plus 2 divided by 3, remainder will be 0. Now it has repeated. Now the things are repeating. After how many terms the things are repeating? What do you think? After how many terms the things are repeating? 0 1 1 2 0 2. So I'll write 0 1 1 2 0 2. Okay, 0 1 1 2 0 2, again 2 1 0 1 1 2 0 2 2 1 0. Now you see 8 terms, right? 1 2 3 4 5 6 7 8. After 8 terms, this thing has again repeated. No, 0 1 1 2 0 2 2 1. Again 0 came. 8 terms. So you can notice the recursion now. Are you able to notice the recursion? Right? We are easily able to notice the recursion. After every 8 terms, the recursion is happening. So 2016, right? After every 8 terms. So 2016th is your multiple of 2016. 1 second. 1 2 3 4 5 6 7 8. And 1. Right? 2016 is a multiple of 2016 is a multiple of 8. Just check once. Just check once. 2016 is a multiple of 8, definitely. Now tell me the answer. You can tell right now. Pick your answer. Wait, I'm not able to see your comments. Let me just. After every 8 terms. Yeah, all 8 terms. So till 2016 is a multiple of 8, definitely. So till 2016, again 0 will, 2016 will be 0 again, it will start from starting. 2016 will be 0 again. Okay. 2017 will be 1, then 2, then 0, 2, 2, 1 and again 0. Right. Then just the sum of all these. So how much is the sum? 2, 4, 5, 6, 7, 8, 9. 9 should be our answer. 9 should be our answer. The series is recursive, correct? After every 8 term, you are getting 0. So 8 multiple of 8, last multiple of 8 before 2017 is 2016. So F 2016 is going to be 0, right? And when F 2017 you will see 1 plus 0 remainder again will be 1. So F 2017 will be equal to 1. F 2016 will be equal to 0. Alright, Ji? Okay, 9 will be our answer. I hope this question is clear for you all. Let me check if there is. Good. Good. Why? Okay, next. Consider the, read this question. Read this question. Okay. Consider the set of numbers 1, 10, 10 square, 10 cube, 10 to the power 10. The ratio of largest element of the set to the sum of other 10 elements of the set is closest to which integer? GP question, straight away, right? Largest element of the set will be 10 to the power 10, and ratio, what we need to find, ratio of the largest element of the set to the sum of other 10 elements. There are 11 elements over here, 10 power 10s and 1 is also there, so 11 elements here. So other 10 elements, that means 1 to 10 to the power 10, sum of these. So largest element of the set is 10 to the power 10. Now divided by sum of other 10 elements, that means 1 plus 10 square plus 10 cube till 10 to the power 9, okay, till 10 to the power 9. So we know how to find the sum. This is 10 to the power 10 and sum of 10 terms of a GP whose common ratio is 10. First term is 1, r to the power n common ratio 10, 10 to the power, how many terms are there? How many terms are there? 0 to 9. That means there are total 10 terms, 10 to the power 10 minus 1 divided by 10 minus 1. Divided by 10 minus 1. Correct? Okay, ji. This is our sum. Now this is going to be closest to 10 to the power 10 by 9, right? Obviously this is, they are asking you closest integer, closest to which integer? This thing is closest to what? 10 to the power 10, because 1 is not making much of difference, so we can approximate it to 10 to the power 10 upon 9, approximate value, right? And 10 to the power 10 divided by 10 to the power 10 upon 9's approximate value will be equal to 9. So the closest integer which is it equal to is 10 to the power 9. So if we have studied carefully, if we know the concepts of AP, GP, formulas and all these things, these questions are not going to bother us. Okay. This question I gave in as a homework in the last class, right? This is the reason we started with telescoping, right? How telescoping happens. For example, this is what? This is sum of n terms. Sn is defined to you as sigma over k equal to 0 to n and 1 divided by square root of k plus 1 plus square root of k. Okay. Now this way we are not able to apply anything. Why? Because this looks like this. If we magnify this, what does it look like? 1 divided by square root of 1 plus square root of 0 plus 1 divided by square root of 1 plus 1, that means 2 plus square root of 0, 1. Now k is, first k was 0, then k was 1, then k will be equal to 2, so square root 3 plus square root 2, right, 1 by, then next of the terms will be square root 4 plus square root 3. This is the situation. Okay, this is what this sigma means. But when there are irrational term in the denominator, we are not being able to do anything about it, right? We are not able to do anything about it. But if whenever such type of thing happens, you know what you do is you can telescope only, you can make it a telescopic series only when there is a difference in between, right? Addition, how will terms get cancelled? So terms are not getting cancelled over here. What you'll do about it is that you'll rationalize this. How do you rationalize? You multiply and divide with the conjugate of this thing. That means square root of k plus 1 minus square root of k, will multiply it and divide it with. Right? Why did we do this? Because now this is going to become from k equal to 0 to n. This is becoming what? Square a plus b into a minus b. This is a plus b into a minus b. That means k plus 1, square root of k plus 1 whole square, that means k plus 1, minus square root of k square, that means k. So k plus 1 minus k will be equal to 1. So this thing is 1. This denominator thing is 1. And numerator thing is what? Square root of k plus 1 minus square root of k. Now telescoping can happen. Now we can hope for the terms being cancelled. So how? If we open this again, what is this? Put k equal to 0, so we'll have square root 1 minus square root 0, right, plus. Put k equal to 1, so square root 2 minus square root 1. Put k equal to 2, so plus square root of 3 minus square root 2. K equal to 3, if we put square root of 4 minus square root of 3. Okay, till n. So square root of n plus 1 minus square root n. Square root of n plus 1 minus square root n. This is going till n. K is iterating from 0 to n. So now you see terms are getting cancelled. This is getting cancelled. This is 0 only, right? This will get cancelled. This will get cancelled. Okay. So last of the terms. See, terms started getting cancelled from here, no? So square root of this, square root of n plus 1 minus n, this negative term will get cancelled, right? What will remain? Square root of n plus 1 will remain. So this thing which is given to us, k equal to 0 to n, from square root k plus 1 minus square root k, this is nothing but square root of n plus 1. The answer is square root of n. The answer till here is square root of n plus 1. Okay, ji. Now this is my Sn, sum of n terms. This is Sn only. Now they are asking you to find they are asking you to find the value of this, n iterating from 1 to 99, and find 1 by Sn plus S of n minus 1. So I know that my Sn is nothing but square root of n plus 1. Okay, I need to find what? I need to find n iterating from 1 to 99. N is from 1 to 99. And 1 divided by Sn plus S of n minus 1 plus Sn minus 1. This is what I need to find. So basically, if I put this over here, what do I have? I want n is equal to 1 to 99, sum of n is equal to 1 to 99, where Sn is Sn. So Sn will be 1 divided by square root of n plus 1, and S of n minus 1. S of n minus 1, just instead of n you put n minus 1. So n minus 1 plus 1 will again become n only. So square root of n plus 1 plus square root of n. Isn't this the same situation which we had earlier? Correct? This is the same situation which we had earlier, right? Again, what we'll do, we'll write it as n from 1 to 99, and this will become square root of n plus 1 minus square root of n divided by 1, right? Reciprocaled again. Rationalized again. And if I look at this closely, what is this? N equal to 1, that means square root 2 minus square root 1. Plus now n will be equal to 2, so square root 2 plus 1, 3 minus square root 2. plus n will be equal to 3, so square root 4 minus square root 3, right, plus square root 5 minus square root 4. It will keep going on. Till what? Till 99. So at 99 what will we have? Square root 100 minus square root 99. Now negative terms. We have started cancelling from negative terms. So 99, square root 99, because previous term, before 99, what will be the terms? Before 99, put n is equal to 98. So square root of 98 plus 1, that means 99, minus square root of 98, right, and plus this. So this will get cancelled. 98 minus 98 will also get cancelled. Only square root 100 will remain. Alright, only square root 100 will remain. All the terms will get cancelled because obviously n plus 1, square root n plus 1 is going to remain. So that means we already know the answer. Square root of 100 is remaining. Only square root 100 will remain. Rest everything is getting cancelled. Oh no, why did we cancel square root 1? Why did we cancel square root 1? Square root 1 is not going to be there. Right? Why did we cancel square root 1? We cannot cancel square root 1. Square root 2 is getting cancelled and square root 1 will remain. Yes, square root 1 will remain. This term will remain. No, first negative term is going to remain. Let's check here also. Acha, here square root 0 was there. That's why we didn't consider. So here square root 1 will also remain. So this will be 10 minus 1. That means our answer will be equal to 9. Answer will be equal to 9. Okay. This is how we were supposed to do this question. Telescoping is happening. Basically, you have to open and check what is happening and finally you will have answer. Okay. To telescope, to make the series telescopic, or in such cases you have to rationalize and then do. You need a negative sign, you must remember. Okay. Next. The first term of the sequence is 2014. This question came in RMO, pre-RMO 2014, and that's why the question also contains the number 2014. Okay. The first term of sequence is 2014. Each succeeding term is the sum of the cubes of the digits of the previous term. Okay. Okay. What is the 2014th term of the sequence? Whenever such question comes to recursive sequence, or if you think that recursive sequence can form, you write the terms. Okay, you write the terms. So term 1 is what? 2014. Term 2, each succeeding term is sum of the cubes of the digits of the previous term. That means term 2 will be 4 cube plus 1 cube plus 2 cube. Okay, so 64 plus 1, 65 plus 8, 73. 73. Okay, 73. Term 3 will be what? 7 cube plus 3 cube. Right? 7 cube plus 3 cube. 49 sevens are 343, na? 343 plus 9. 352 you'll have. And just check, I'm doing the calculation correct, no? 343 plus 27. 343 plus 27, this will happen. No, 343 plus 27 we are doing. 380 will be our answer. I think something recursive will form. So far, though, I'm not seeing anything. But 370. Okay. Alright. Just check writing 3-4 terms. You also write. I'm sure that you'll observe what is happening. Check a couple of more terms. Okay. T4 will be what? 3 cube plus 7 cube. 370 only. T5 will be what? 3 cube plus 7 cube. 370. How easy this was. We just had to write some terms. So obviously after the second term, all the terms are going to be equal to 370. Because 3 cube plus 7 cube is always going to be equal to 370. All the terms, so 2014th term, be it any term, this will also be 370. What's the problem? Now the sum cannot change, now the terms cannot change, right? 2014, 73, 73 will give you 370, and after 370 you cannot do anything. All the terms will be equal to 370. So 2014th term is also 370. So I think this was the easiest question in 2014 then. What do you think? Chaliye, next question. Let U, V, W be not Rala numbers, real numbers. Real numbers. Real numbers in geometric progression such that U is greater than V and V is greater than W. Okay. U to the power 40 is equal to V to the power n is equal to W to the power 60. Find the value of n. They are asking us to find the value of n. So because they have already given us that U, V, W are in geometric progression. U, V, W are in geometric progression. We know if A, B, C are in geometric progression, then B square is equal to AC. So we already know that V square will be equal to U, W. U multiplied with W. Okay. This we already know. Now what we can do is, we already know, okay, we can use this now. Now we are going to use this. What we can do is V to the power n is some W to the power 60 divided by n. Okay, like that. Or if we can create everything in W to the power 60, try to create everything in W to the power 60. U to the power 40 is equal to W to the power 60. For example, we have U to the power 40 is equal to W to the power 60. This is given to us. So U will be equal to what? W to the power 60 divided by 40. This we know. Right. So U will be equal to what? W to the power 3 by 2. Right. U will be equal to W to the power 3 by 2. Now V square is equal to U into W, and U itself is W to the power 3 by 2. So W to the power 3 by 2 into W we can do. And 3 by 2 plus 1 will be 5 by 2. So V square is equal to W to the power 5 by 2. And we can also say that V will be equal to W to the power 5 by 4. Right? This 2 will also come, no? 5 by 2 divided by 2. So 5 by 4. Right? V is equal to 5 to the power 4. Now V to the power n is equal to W to the power 60. Right? Both sides, if we take power n, V to the power n will be equal to W to the power 5 by 4 to the whole power n. Right? Right? And this V to the power n is equal to W to the power 60. So basically what did we get? We got W to the power 5n by 4 is equal to W to the power 60. Correct? It's already given, no? V to the power n is equal to W to the power 60. We got V. First we converted everything in W. We got V. We put power n on both the sides. Yes, we can put. Right? And real numbers they are, no problem. So 5n by 4 will be equal to 60, and I got n. 5n by 4 will be equal to 60. So n will be equal to 60 into 4 divided by 5. 48 will be our answer. N will be equal to 48. Okay, n will be equal to 48. Very easily we could solve. We just needed to use the property of our GP. This thing. We just needed to use V square is equal to U into W. Why? Because the terms are in GP. And just like in AP, if 3 terms are in AP, if ABC are in AP, then we know that A plus C, arithmetic mean, will be equal to B. And if A, B, C are in GP, geometric progression, then geometric mean A and C will be equal to B square. A into C will be equal to B into B. Okay. Next. 1, 2, 3 till, this 1, 2, 3 till n, where n is greater than 2, are written on a board. This is 2017 question. Are written on a board. 2 numbers m and k. This is 1. First of all, this is 1. This is n. Yeah, this is n. This is 1. This is n. If the question is not clear, m and k. This is not dot. This is a comma. Sorry for the typing mistakes. Integers 1, 2, 3 till n, where n is greater than 2, are written where n is greater than, acha, n is greater than 2. There is something fishy in this question. Let me check this question once again. Just a minute. Where is this question? Yeah, 1, 2, 3 till n is greater than 2 are written on the board. Two numbers m, k such that, and the average of the remaining numbers is found to be 17. Chale, try this question. No, question is correct. They are saying integers 1 till n, where n is greater than 2, are written on a board. Okay. Two numbers m and k, there are two numbers m and k such that these numbers lie between 1 and n. Both m is also between 1 and n and k is also between 1 and n, are removed, and the average of the remaining numbers is found to be 17. What is the maximum sum of two numbers removed? What is the maximum sum of two removed numbers? Very logically, very mathematically you will have to think about this question. This is a good question. Okay, come on, give it a try. Now, how can we approach? First, let's see how will we approach. They are saying m is between 1 and n and k is between 1 and n. What we do is, they want us to maximize the sum, right? I know that sum of this 1 plus 2 plus 3 till n, this is equal to n into n plus 1 divided by 2. I know this sum of first n natural numbers, the sum is equal to n into n plus 1 divided by 2. So sum I know. Average of these will be equal to what? Average. Average will be equal to n plus 1 divided by 2, because you will divide the sum divided by total number of numbers. So n into n plus 1 divided by 2 upon n. Okay. Now they are saying two numbers m and k are removed and the average of the remaining numbers is found to be 17. So basically what they are saying is that when you two numbers are removed, no? So average including m and n, somewhere let's say 1, 2, 3 plus 4, somewhere m is coming and somewhere k is coming, right, and n is over here. So right now the average is total n numbers. Okay. Now what we are doing, removing two numbers. What we are doing is removing two numbers. So right now the sum is n into n plus 1 divided by 2. Now I want to remove m and n. So now what will happen? n into n plus 1 divided by 2 will be the sum of all n numbers minus m plus k. Right, two numbers m and k I am removing, and divided by what? N minus 2. Two numbers are removed, no? Two numbers are removed. So total number of numbers, sum divided by total number of elements is the average. This is what they are saying. This is equal to 17. Now they are asking us what is the maximum sum of the two removed numbers. So minimum sum will be what? Minimum sum will be what? N is always greater than 2. So minimum sum will be when 1 and 2 are removed. Maximum will be when n and n minus 1 are removed. Correct? Right? Maximum will be when n and n minus 1 are removed. So minimum, let's say, if we remove, let's remove the smallest of the numbers. 1 and 2 are the smallest of these two numbers. Let's remove 1 and 2. What will be the average? N into n plus 1 divided by 2 minus 3 divided by n minus 2. Two numbers are removed, no? So n minus 2 over here. What will be the value of this? Let's calculate. N square plus n, leave it like this, n into n plus 1 minus 6 divided by 2 into n minus 2. Okay, so how much this comes? N square plus n minus 6, 3 and 2, let's see. So this, we can factorize this, no? N square plus n minus 6 divided by 2 into n minus 2. Can we factorize this? Plus 3 and minus 2, yeah. N plus 3 and n minus 2. So this will be n plus 3 into n minus 2. Okay. And divided by 2 into n minus 2. We can write it like this. N minus 2 got cancelled. And we have n plus 3 divided by 2. This will be the minimum sum obtained because we are removing the smallest of the numbers. First two. Right. Now let's remove the last two numbers. N and n minus 1. Now let's remove n and n minus 1. Suppose we are removing the last, whatever is the possibility. Okay, why? Because maximize, if we want to, why am I doing all this? Because if you want to maximize, right, something, if you want to maximize something, you need to create a inequality, and to create that inequality I need some information for m and n. So I am seeing what is the maximum range, right, smallest and largest. Now my m plus n will remain between these two only, no? Okay, so if I removed n and n minus 1, suppose these two numbers I am removing, so my average will be n into n plus 1 divided by 2 minus n plus n minus 1 minus n plus n minus 1. So 2n minus 1, 2n minus 1. Here I will get 2n minus 1 divided by n minus 2. Now let's calculate this. So n square plus n minus 4n plus 2. Okay, divided by n minus 2. Now this will be n square minus 3n minus 2 divided by n minus 2. So minus 2 minus 1, no, 2, 1 minute, something's wrong. Minus minus plus, this will happen, no? So plus 2. Wait, here we did something wrong. Just a minute. So let's write a couple of more steps, not a problem. N square plus n minus 2 into 2n minus 1 divided by 2 into n minus 2. This is what we are getting. So this will be n square plus n minus 4n plus 2 minus 4n plus 2 divided by 2 into n minus 2. Okay, so now this is minus 4n, here was here minus 4n, n minus 4n plus 2. So minus 3, this will become n square minus 3n plus 2 divided by 2 into n minus 2. So minus 2 minus 1, n minus 2 into n minus 1, right? This will become n minus 1 divided by 2, right? N minus 2 into n minus 1 are the factors. N minus 2 will get cancelled and we'll have n minus 1 into 2. Okay. So this is our average when we are removing the last of the two numbers, right? Last of the two numbers. And now let's remove m and n. So when we are removing m and n, we have n into n plus 1 divided by 2 minus m and k. M and k, na? M and k there were. M and k there are. M and k. Yes, m and k are there. Minus m plus k. Okay. Divided by n minus 2 because two numbers are removed. Right. Now let's solve for m and k. Now we can solve for m and k. Come on now. Now tell me. Let me read the comments if there are any. Are we able to understand? No, sound is not. Sound is clear only here. On my system, it's showing clear. Hanji. So now whatever our average is going to be will be between these two, right? N minus 1 by 2 and the other one which we got. Whatever our average is will be between these two. Whatever our average is, that average will be between n plus 3 by 2 and n minus 1 by 2. Am I correct or not? Tell me. Whatever average we are getting, because we found the outer limits, no now. However, whatever average we get, it is going to be lesser than this. Why is this not getting connected, man? Okay, I hope this thing is clear, right? Whatever average we are going to get in this case will definitely be between n minus 1 by 2 and n plus 3 by 2. So far we have got this thing. Okay, ji. Now what was the average given to us? Average was given to us as 17, right? 17, right? So my 17 has to be between this thing. 17 has to be between n plus 3. It has to be greater than n plus 3 by 2 and it has to be smaller than n minus 1 by 2. Am I saying the correct thing or not? It has to be smaller than n minus 1 by 2 and it has to be greater than n plus 3 by 2. So I'll solve this thing. I'll say, okay, 70, I want n plus 3 by 2 to be less than 17. So my n will be equal to 34 minus 3. That means n should be less than 31. Correct only we are doing, no? And n minus 1 by 2 should be greater than 17. Right? So now this gives me 34 plus 1, 35. N should be greater than 35. We did ulta we did. Ulta we did. Right? N 17 should be greater than n plus 3 by 2 and less than n minus 1 by 2. Right? So I'll get n will be between 35 and 31. Right? N will be between 35 and 31 by solving this. Why did I do this? Because minimum average I can get is n plus 3 by 2. Last two numbers if I get. If I remove the largest of the numbers, minimum average I'll get. And if I remove the smallest of the numbers, maximum average I'll get. So maximum average is this, minimum average is this. So whatever is 17 is going to stay between these two. And with that I get n will be between 31 and 35 and n is an integer. So n's possible values are 32, 33 and 34. These three possible values I can get for n. But obvious, correct? If this is obvious, then I'll just check over here. On n is equal to 32, you check what value you are getting. 32 will be 16 into 33 minus m plus k divided by 32 minus 2, that means 31. Okay. This should be equal to 17. This is equal to 17. So what are we getting for m plus k? So find the value, no? M plus k will be equal to 16 into 33 minus 17 into 31, right? And if you put n is equal to 33, what are we getting? M plus k. So this will become n into n plus 1, that means 33 into 34, 33 into 17 minus m plus k, right, divided by n minus 2, that means 30, n minus 2 it was kya? So this will be 30 and here also we'll have 30, okay, right? If n minus 2, so this will be 31 equal to 17, so you'll get m plus k is equal to 17 into 31, okay, 17 into 33 minus 17 into 31. Right, this will be your m plus k value. Now you just need to check which is the maximum. In the third case, n is equal to 34. For n is equal to 34 also you can check the value of m plus k. One maximum you will get. I think at 34 you should get. I'll calculate it quickly. I'll just calculate quickly. N is equal to 34. So for n is equal to 34 you will get 34 into 35 by 2, that means 17 into 35. So this will become 33 minus 2, 31. Okay, so we'll have 17 into 31 minus 17 into 35. Wait. 17 into 35 minus 17 into 31. Yeah, 17 into 35 minus 17 into 31 you are going to get. Let's check the answer. 17 into 35 minus 17 into 31. 68 we are getting over here. Then 17 into 33 minus 17 into 31, although we can calculate it also. Right, this will be your maximum of the values. Right, for n is equal to 34, For n is equal to 34, we are getting 51, right? So 51 will be your maximum value. When n is equal to 32, you got m plus k is equal to 18, right? Just put it equal to 17, right? Just check. I'll write and calculate once again. Just this thing you need to check, okay? For n is equal to 32, n is equal to 33 and n is equal to 34. I'll just calculate and tell you 33 and n is equal to 34. So for n is equal to 32, you will be getting m plus k is equal to 18. M plus k will come out to be equal to 18. For n is equal to 33, what were we getting? Just a minute. We were getting 34. And for this one, we are getting m plus k is equal to 51. Anyway, at n is equal to 34, we are going to maximum. We were going to get the maximum value, which is 51, and 51 will be our answer. Maximum of m plus k will be equal to 51. Good question. This is how you are supposed to solve this. I hope this made a lot of things clear. Chaliye, let's go ahead. This type of question you must have solved earlier also. This came in 2018. I hope you know the method to solve it. So we have 6 plus 66 plus 666 plus, so here we have 100 times 666, 666, 100 times. This is last digit contains 10066, 106, right? All these 6s are 100. Okay. Anybody who has solved this type of question? Anybody who has solved this type of question? Right, very regular type of question. No, many students must have solved it somewhere or the other. Very regular type of question. Right, if you are solving number series also, number system questions also, then also you will get such type of a question. Then also you definitely get what is the idea? First you take 6 common. First what you will do? You will take 6 common, right? So this will become 1 plus 1 1 plus 1 1 1 plus 1 1 1 1. And you will have 1 1 1 1 1 1 1 1. This will be 100 times 1, 100 ones. Okay. Now, what next step should be? Try to create 9s, because you need to make a GP. This is not a GP right now. This is not a GP right now. Right? This is not a GP right now. So what you do? GP, how can you create? In terms of 10, you try to create GP. How do you do that? You divide by 9 and multiply by 9 inside. So inside what will you have? 9 plus 99. Plus 999 plus 9999 and here 100 nines. Okay, here you will have 100 nines. You divided by 9, multiplied with 9. Now what is the idea? Next is you will have 6 by 9 and all these 9s. 9 can be written as 10 minus 1. 99 can be written as 100 minus 1. Right? 999 can be written as 1000 minus 1. Okay, correct. Okay, 10 to the power 100, right? Because minus 1. This is 10 to the power 3 minus 1. This is 10 to the power 1 minus 1. 10 to the power 100 minus 1. Last term will be 10 to the power 100 minus 1. Okay, so 6 by 9. 1 we have 10 plus 10 to the power 10 square plus 10 square 10 to the power 3. Right? Likewise, are you able to understand this? Clear, right? Right, minus 100. Now 100 terms are going to be there, obviously. Right, 100 terms are there. Can we see that? 100 terms are there, no? Because last term contains 106. So 100 terms are there. If we are subtracting 100 times, if we are subtracting 100 times, that means here what we'll have? Here we'll have 10 to the power 100 and minus 100. Correct? If we are subtracting 100 times, that means 100 will come, negative 100 will come. Okay, this series we know how to solve. This is a GP, 10, 10 square. This is a GP. First term is 10. Common ratio is 10. How many terms we are looking for? We are looking for 100 terms. Till here we have 100 terms. 1, 2, 3, 4. Till here we have 100 terms. So 10 to the power 100. 10 to the power 100. R to the power n minus 1 divided by 10 minus 1. That means 9. Divided by 10 minus 1, that means 9. Right? And minus mein this 100 is also there. Minus mein this 100 is also there. Now this is what 2 is 2 by 3. Okay, let's write it as 2 by 3. Then here we have 10 to the power 100 minus 1. Now think about what is the question asking. Question is asking how many times does the digit 7 occur in number n, right? So we'll have to solve it a little bit more to understand how many 7s will occur over here. Okay, whatever this is, 10 into 10 to the power 100 minus 1, right? What will it have? 10 to the power 100 will have some 100 zeros, right? Correct? 100 zeros will be there. Now 100 zeros, 10 to the power 100 into 10, this will be 10 to the power 101 minus 10 divided by 9 minus 100. Let me write one more step. So 2 by 3 into, not 10 to the power 100 minus 10. This will have 9s, right? How will this be? 10 to the power 100 and 10 to the power 1010 zeros, matlab 1 after 1, 101 zeros minus 10 if you do. So last digit will be 0, remaining 100 digits will be 9, right? After 100 zeros, and from that you are doing minus 10. So last digit will be 0, but remaining by minus 10 if you do, last digit will be 0. All these will become 9, no? Right? So how many 9s are going to be there? Think about it. How many 9s? 100 9s will be there and last digit will be 0. So this will be 9, 9, 9, 9. 100 9s will be there and last digit will be 0. So till here we'll have 100 9s. 100 9s will be there. Last digit will be 0. And this is divided by 9 and minus 100 is there. Okay, minus 100 is there. Correct? Now you tell me this 2 by 3, all these will be 1, 2 by 3, right? All these will be 1, 1, 1, 1, 1, 1, 100 ones, last digit will be 0, minus 100, right? Because we are dividing by 9, right? Now after doing minus 100, last 4 digits will be what? 1010. Last 4 digits will be 1010. Before that, 98 times 1 will come. Before that, 98 times 1 will come. Correct? I am writing it on the next page. 2 by 3. Right? What did we have? 1, 1, 1, 100 times 0 minus 100. So minus 100, 2 zeros, 0, 0, 0, 1 and 0, 1. Right? So suppose we have 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, over here 0 and you are subtracting 100. So 0, 1, 0 and 1. 4 will be 0, 1, 0, 1. And remaining of the digits will be 1 only. Same 1 will come because we are subtracting 100. So 1, how many times 1 is going to come? 100 times 2 zeros less, so 98 times this 1 will come. Think about it on your own. Then only you will be able to understand and do it. Right? 98 times 1s will come. Then last will be 0, 1, 0. Last will be 0, 1, 0. Okay? Till here, 98 times 1 is going to come. Now this you are multiplying with 2 by 3. Okay? So 2 if you multiply inside, this will become 2, 2, 2. 98 times 2, 0, 1, 0, 0, 2, 0, 0, 2, 0. Right? 2, 0, 2, 0 will be last and this divided by 3. Okay? Now try dividing and you will see there is a pattern here also. Try dividing, you will see there is a pattern here also. Try dividing 4 2s only, you will understand that there is a pattern. So this will come like this, 740, 740, 740. This is going to repeat itself. Right? Till 96 of the, only the last one, only this 0 to 0 will not get divided, remaining all will get divided. Last will have 340, till here will have 7, till this 2 will have 7, last may will have 340. All these, this is a repeated pattern. 96 times, when you divide, no, you will understand 96 times 7 is going to come. Right? After every third digit 7 is coming. So in 96 every third digit divided by 3, 33, 32 and plus this 7 will also come. Right? Plus this 7 will also come. So there will be 33 7s. There are going to be 33 7s. Do it on your own, then only you will be able to understand. Right? Divide this. Divide just 4 2s by 3. You will see 7407. Right? You will understand 7407 is going to repeat. Okay. 3 sevens are 21, 1, 2, 3 fours are 12, 0, 3 sevens are 21 again, right? So same thing is going to repeat. 740, 740, 740 will repeat. For the last one, 0 to 0, we'll have 340, right? Here we'll have 340. 20, 20 will be giving us 340. Okay, ji? Right. Let's go ahead. Next question. 33 sevens are going to be there. This is one question, right? This came in 2021 IOQM. Okay. So we'll have to simplify this. Whatever is there in sigma, if we see, what is it saying? If we put k is equal to 1. So 2 into 1 plus 1, that means 3, divided by 1 plus 1, that means 2 square, plus, then put k is equal to 2. So 4 plus 1, 5, divided by here what we'll have? 4 plus 2, 6 square, right? Third term will be 7 divided by 9 plus 3, 12 square. Okay. So no pattern. In this way we are not able to see any of the pattern. Okay. In this way we are not able to see any of the pattern. What shall we do? Any idea? Any idea? Come on, tell me. Come on, try this. Give it a while. Try this question, guys. So we will have to simplify it a little bit, obviously. Okay, we'll have to simplify it a little bit. But how? See, if we take k common from the denominator, let's say, if we take k common from the denominator from here, k, so we'll have k plus 1, right? And this 2k plus 1 also can be written as k plus 1. Correct? First idea, first thought of approach that we can do, right? So what am I going to do is, in the denominator I have k square into k plus 1 whole square. Can I write it? K common. So k into k plus 1 it will be. So k square into k plus 1 whole square. And here I am writing k plus 1. Okay. Sigma is over this. 1 to n. Right? 1 to n. Now what am I going to do is sigma. Okay. Now k. Now I can split it. K divided by k square into k plus 1 whole square. Plus k plus 1 divided by k square into k plus 1 whole square. Either I can split and do something. So try. Can we do something like this? What do you think? Or should I split it like this or some other way? Because I want to make telescopic series, something like telescopic series. Otherwise, I don't have any idea how will I take this forward. So this way I am not seeing anything which we can do about it, right? Instead, we can, if we separate k square, suppose if we do like this, 1 by k square plus 1 by k square just like that, plus k plus 1 divided by k square into k plus 1 whole square. If I do like this, what happens? Something better? Can you see? Or, right, k, or one more method is there, that if I do 1 divided by k into k plus 1, I don't want square, right? So 1 divided by k into k plus 1, I can keep it like this only, right? Multiply it with k into k plus 1 divided by k into k plus 1. This way if I see it, this way. Why? Because we have learned how to make a telescopic series. This one we can make. This is 1 divided by n into n plus 1. If you remember the starting questions, here something telescopic will be formed. But remaining I am not able to form anything. correct? And here also I'll be able to split it. So now same thing I'm writing like this, k plus 1 minus, okay, leave it, k plus 1 minus k divided by k into k plus 1. This one I'm writing like this. Just like the starting questions which we did. If you understood those, you'll be able to understand these also. And here what am I going to do is, k divided by k into k plus 1, that means 1 divided by k plus 1 plus 1 divided by k. Two multiplications I have formed, right? And now this thing, if you observe, the first bracket, this is what? 1 divided by k minus 1 divided by k plus 1. Correct? And the second bracket is 1 divided by k plus 1 divided by k plus 1. Wow, this is something I can deal with, because this is a square minus b square now. This is what? A square minus b square now. Correct? So my sigma is nothing but, sigma is, I have broken down my sigma as 1 by k minus 1 by k plus 1 by k plus 1 into 1 by k minus 1 by k plus 1. Right, I could have done with other forms of fact, like if I solve and factorize, no, that way also I'll be able to do it. But still, now this way, this thing is looking much more better to me now. Right? Why? Because this is 1 by k square minus 1 by k plus 1 whole square. Correct? A square minus b square. K is iterating from 1 to n. Right? Now if I write the terms, now if I start writing the terms, right, if I expand this, k is equal to 1 means 1 by 1 minus 1 by 2 square, correct, plus k is equal to 2 means 1 by 2 square minus 1 by 1 plus 1, 1 by 3 square, okay, plus k is equal to 1 here, k is equal to 2, k is equal to 3 now. So 1 by 3 square minus 1 by 3 plus 1, that means 4 square, plus 1 by 4 square minus 1 by 5 square. Correct? In the end, what will I have? In the end, 1 by n square minus 1 by n plus 1 whole square. Before this, if before this, what will be the term before this? Right? Put n minus 1, no? At n, that is the term. At n minus 1 will be what? At n minus 1, what are we going to have? 1 by n minus 1 whole square plus minus 1 by n square. Correct? So which of the terms are getting cancelled? This, all these will get cancelled. Even this will get cancelled and this will cancel this one. What will remain? What will remain? Can you see it? What will remain now? Right? Which of the terms are remaining now? Only one is remaining, and the last term, that means 1 by n plus 1 whole square, negative of that. So my sum of n terms is nothing but 1 minus 1 by n plus 1 whole square. This is my sum. This is my sum, which is given to me as 0.9999. This is my sum. Okay. So my 1 minus 1 divided by n plus 1 whole square is given to me as 0.999, 0.9 bar. Right? 0.9 bar. Okay, so you will do just 1 minus 0.999, that means 0.001. How many 9s were there? Let's see if they were finite or not. 0.9999. Okay, so what you can do is, now you will just simply do 1 by n plus 1 whole square will be equal to 1 minus 0.9999. Okay, right, this is what we are getting. Now we can find our answer very easily. Okay, this will be 0.0001, right? This will be 0.0001, 0.0001. So 1 divided by 10,000. That means 1 by 10 to the power 4. Okay, ji. 1 by 10 to the power 4. We can find n from here now. Any problem? Anybody? Right? 1 by 100 square is equal to, simply just do no, n plus 1 will be equal to 100. So n will be equal to 99. This is the sum of 99 terms, and they asked n only, right? They asked n only, yeah. So try to make a telescopic form. This is how you can do such questions. All right, let's move ahead. Okay, that's I think all for now. Some of the more things which I wanted to. Acha, we did multiple sigma also, right? If we have more than one sigma, have we discussed those type of questions? I think we have, right? I think we have. Method of difference also we have discussed today. Telescoping also we discussed. So almost all the things we have discussed, and we have seen some PYQs also of IOQM today. So I think we are now sufficient enough, able enough, if we have followed all the 4 lectures. Now we have enough information and have enough knowledge to solve the PYQs of PRMO or IOQM. Okay. So do solve as many of them as you can. Today also we have solved somewhere around 8 to 9 PYQs, 9 to 10 PYQs, more than that I think, right? First ones which we solved, no, those were also PYQs. Okay, those were also PYQs. So yeah, we are good to go. Now you can solve as many questions as you want. If you have any doubts, if you want more lecture, if you have some couple of questions or a set which you want to be discussed and solved, put it in the comment box, right? Don't forget my name. My name is Ayush Patni. Okay, put it in the comment box. I'll take more lectures if you need so, right? Or if something is not clear, if you want some more questions or some more discussion on telescoping thing or GP, AP, AGM, anything, you can tell me in the comment box. I'll come again and put up a lecture for you, right? So you have enough time now for IOQM. The registrations have started, guys, and the link is there in the description also. The link for registration for your exam is also there in the description box. So there you can just click on that link and register yourself for the exam. That'll be good. You are well practiced. Do some more questions, right? From the books you are referring, from the modules you are referring. Do as many questions as you can for recursive series, and be confident about this topic, because very simple. You saw that very simple questions were also there and some tricky questions were also there. But if we are thorough with the concepts, will not be getting stuck at any of the questions. We don't need to, right? Everything will be good. All right then, take care, have fun, and all the best.